Hello everyone, this is a solution to the second part of problem 2 from my spring 2020 final exam. So here, just as in the previous video, part A of this problem, we're told that we're supposed to use our interpretation of integrals as accumulations in order to compute a definite integral, right? So we're not using the fundamental theorem of calculus. We really want to use properties of the function that we're integrating. And so looking at this function, we notice that we have a polynomial. And let's take a look at the degrees of each of the powers of x. Of course, we have x to the fifth, we have x to the cube, or x to the third, and then there's also, well, we could write a 1 in here if we aren't sure what that is. And one thing we might notice, 1, 3, 5, these are odd numbers. And that suggests that maybe we have an odd function, yeah? Now, this is, of course, a general fact. If you have a polynomial and all of the degrees for the individual pieces are odd, then you actually do have an odd function. Let's verify this, right, in this particular case. So here I have some f of x, which I'll call 19, x to the fifth minus 12x cubed plus 7x. And to be an odd function, that means you take the additive inverse of x, that is, you put in negative x, and you want to show that your output is just the negative of the original output, right? That is negative f of x. So let's see here. So this would be 19 times negative x to the fifth minus 12 times negative x cubed plus 7 times negative x. And this is where the odd degree matters, right? Each one of these fifth powers, third power, first power, when it hits that negative sign, is not going to change anything, right? You could think of negative x as negative 1 times x. So if you have negative x to the fifth, this is the same thing as negative 1 to the fifth times x to the fifth. And if you raise negative 1 to an odd power, you get negative 1. Okay, so in each of these cases, this negative is just going to float to the front. So since each one of them gets a negative, I can pull that negative out. And I'll be left with negative times the quantity 19x to the fifth minus 12x cubed plus 7x. But of course, this is negative f of x. So this implies that our function f is an odd function. So we may not know exactly what the graph of our function looks like, but we do know that it has to look something like this in the sense of it has these properties. On the right-hand side versus the left-hand side, you're getting the same shape, just inverted, right? Everything is upside down, which means if I compute the area under the curve from 0 up to some point A, and then I go to the other side of the curve and compute the area, which now will be negative, right? So we take the signed area. If I compute that to negative A, then these are going to be the exact same other than the fact that there's a negative sign. Which means if I integrate from negative a to positive a, an odd function, I'm going to get 0. So in this case, well, we notice we have negative 100 to positive 100. So we're exactly in this situation, and so the answer to this question is a big fat 0.